Hello everyone, welcome to my channel. My name is Vinod and today again we are going to see how to convert the Lagrangian equation to Hamiltonian equation. So let's start. So for solving these questions, we should know these few things like this L Lagrangian equal to T minus V, where T is kinetic energy and V is the potential energy. Second, Lagrangian should be function of Q and Q dot and your Hamiltonian should be function of Q and P. Point number 3, dou L by dou X dot is equal to Px. And point number 4, L is equal to sigma Q dot P minus H or X dot P minus H. These four things we need to know. This thing we should know so that we can solve the questions very easily. So let's take some questions here. So this is the Lagrangian given to you and it is asking about Hamiltonian system. Okay. So let me write first Lagrangian. L is equal to 1/2 m. I'll put here Q dot is X dot square minus lambda by 2 X dot. I'm putting X just to not make mistake. Okay. So first thing is what we need to do, we have to do dou L by dou X dot is equal to Px. And if we'll do dou L by dou X dot, what we will get? We'll get mx dot minus, this is square, mx dot minus lambda x dot. So this is equation number 1 and this is equation number 2. So from equation 1 and 2, what you will get? Px is equal to m x dot is common, so m minus lambda x. So from here your x dot will be Px upon m minus lambda x. Okay. Now the formula number 4th, that H should be sigma x dot P minus L. So we'll put x dot in this equation. So what we'll get? Px upon m minus lambda x, and Px is already there, so Px is square minus L. So L is here. Now we'll keep that here. So 1 by 2 m x dot square. So it will be Px square upon m minus lambda x whole square. And minus, so plus the second term will be lambda by 2 q. And q dot square means x dot square, so it is Px square upon m minus lambda x whole square. So if you solve this equation, so I'll put first term as it is, Px upon m minus lambda x. And if I'll see the term number 2 and third term, we are getting common here, Px square upon 2 m minus lambda x square, right? So what you will get? You will get inside m minus lambda x, right? This is x. Okay. So this is m minus lambda x and this is m minus lambda x, so this will be cancelled. So what you will get? Px square upon m minus lambda x minus Px square upon half m minus lambda x. So if you solve it, this is 1 and this is 1 by 2. So what we'll get? 1 by 2 Px square m minus lambda x. Now I'll convert this in terms of, I replace x by q. So it will be 1 by 2 p square upon m minus lambda q. So this is your Hamiltonian. Okay, so now let's see. So your answer number B is the matching with our answer. Option B is the correct. Okay, p square upon 2m lambda x, p square upon 2m lambda x. Okay, so let's take one more question. So here our Lagrangian L is given and it is asking about Hamiltonian. So our L is 1 by 2 m x dot square plus m x dot y dot. Okay, so here you have two coordinate, right, x and y. So let's see how it will be done. So first part we will do dou L by dou x dot. So what you will get, dou L by dou x dot, you will get m x dot plus m y dot, and generally dou L by dou x dot will be px. So what we can write, px is equal to, suppose this is equation number 1, this is equation number 2. So from equation 1 and 2 we can write px is equal to m x dot, okay, m common, x dot plus y dot. Okay, now we have here second variable also, so we have to do dou L by dou y dot. So what we'll get, this term will be 0, first term will be 0, second term will be m x dot, right? And generally if we'll write dou L by dou y dot will be py, right? So suppose this is equation number 3 and this is 4. So from 3 and 4 what you can write, py is equal to m x dot, right? So from here you can write x dot will be py by m. So we have to calculate y dot also. What will be the y dot? So this value, this, suppose this is equation number b and this is a. So we'll put the equation number b in equation number a. So what will happen? Px is equal to m x dot plus m y dot. This is your equation. So if I'll put here x dot, so px is equal to m, x dot is py by m plus m y dot, right? So these two will be cancelled. So px minus py is equal to my dot. So what will be y dot? Y dot will be px minus py divided by m, right? Now these two equation number b, and let's take this equation number c, we have to put in the Hamiltonian formula. So let me write the Hamiltonian formula first. So that is h is equal to sigma x dot p. So here we have two terms, right? So it will be x dot px plus y dot py minus l. That is why we are putting sigma. So if we have two terms, we can put it here, both of them. So let's put it here. So x dot. So x dot is what? Py by m, right? And px is already there. So px py by m plus y dot. Y dot is what? Px minus py by m, and py is already there, minus l. So our Lagrangian is here. So we'll put the value of, this is our Lagrangian. So we'll put our value x dot y dot there, and we'll see what we are getting. Okay. So it will be 1 by 2 m x dot square, right? So x dot square will be py square by m square, and second term is minus m px py, right? So m x dot y dot, so it will be py by m and px minus py by m y dot, right? This is y dot, this is x dot. Okay, now if you solve it, so first term will be px py by m, second term it will put multiply py inside, so it will be px py by m minus py square by m. Then here m will cancel with one of the m, so it will be py square by 2m, and if you come here, this m and m cancel, so if you multiply again py here, it will be minus px py by m, and last term will be minus and minus plus py square by m, right? So if you see, so this will be cancelled with this, right, and this will be cancelled with this. So what you are getting px py by m minus this term py square by 2m. So what you are getting, your h is equal to px py by m minus py square by 2m. This is your Hamiltonian. Now let's see what is the answer, correct answer from the given option. So if you see, the option number C is matching with our answer. Okay, so this is how you can convert the Lagrangian equation to Hamiltonian equation. I hope it will be clear, and please like this video, share with your friends, subscribe to my channel, and if you have any query, any doubt, please contact me at vrphysics21@gmail.com. Thank you so much.